Thanks, Prof Hano. So you guys all know Prof Hano. He's spoken to us about the plum marbling effect. I've got the personal experience. I've got a 4-year-old African Delight orchard in Stellenbosch, and 2 years ago in second leaf, I had to cut about 10% of those trees away. So, Prof Hano, we would like to hear what is the latest, and also all credit to Rachelle Bester, Dr. Rachelle Bester, that's went to the CRI. So, Hano, thanks a lot.
Righto. Dalk hier 'n bietjie laer, ek 'n bietjie korter ja. Okay. Righto, kan almal my hoor? Joi, middag. Amper tyd om te begin. Luister, ja, Engels. Good afternoon everyone. I have been known as Prof Kirk as well in the marbling world. It's seeing that I'm now currently the face of marbling. So not such a nice position to be in, but the brains behind marbling is my colleague Rachelle Bester. So I just would like to acknowledge that. So unlike Marno, I already have a long title, and unfortunately this was one of those projects that het bietjie kleintjies gekry. So I think the more accurate description of this project would be establishing the cause, plus the development and validation of detection assays and their SOPs for marbling and corky flesh in Japanese plums and apricots. So that is more or less what we've done. To go a little bit away from convention, I've decided, because it's so late in the day, that I'm going to start with the conclusions and just give you the bottom line. Then I'm going to ask and answer my own questions. And then with the time that's left, which will be about 15 minutes, I think, I will try to tell you how we came to those conclusions. So that's more or less the plan. Okay, so for those of you that don't know, you have an absolutely new pathogen in plums. We called it generically plum viroid 1, because it was the first viroid to be detected in plums. There are only like 35 known viroids, so this is fairly new. Unfortunately for us locally, it has not been reported in any other countries yet. There has been reports in Japan in the mid-60s that have photos of symptoms that are suspiciously similar, that was linked to another viroid that might be our viroid, but no official links to other wilts. So we don't know where it comes from. We know that it spreads through propagation material predominantly, and we don't know if there are other means of spread. And we have now developed multiple different tests to test for this viroid. So there's no more excuses to keep it in the industry. Okay, so one of the questions that I expected to get was, could this have been prevented? And it's not an easy answer, a question to answer. So it's yes and no. The presence of this disease, it wasn't possible to sidestep it completely. It would have arrived regardless of what efforts we took or preventions that we took. But I think that the impact of this disease could have been mitigated, provided that we had certain measures in place. But there are verzachtende omstandighede. Now my English is getting thin. Extenuating circumstance. So when you have a new pathogen, it's extremely difficult to detect it and to work with it and to characterize it, especially if you have no detection method. If you have no ways of knowing what you're looking for, or you cannot trace it, it is extremely difficult. So this is something that is very hard to address, especially with the technologies that existed 25 years ago when this disease started emerging in our industry. Then there's a critical shortage in expertise. South Africa has not trained a plant virologist in the last 25 years, and I can't see that we will be training any plant virologists anytime soon. This is particularly bad in South Africa, but it's also an international trend. The way I like to look at it, I feel like plant virologists are like firefighters. We spend a lot of time in the station, and we go out and we do things to prevent fires. So, and we try never to fight a fire. So we try to prevent fires all the time, but if people don't believe in fires, then you don't have a fire station. So this is something that we need to get around and find a mechanism to keep people working on problems before they become big problems. Then a question I think has been answered more or less with the previous two speakers, and I hope I didn't know the percentages. It seems like in the plum industry I'm almost preaching to the choir, but when you decide to plant a new orchard, plant material should not be part of your decision model, the plant health. That should be a given. Plant health should be first. You need to have decided fundamentally that all plant material that you plant will be of healthy origins from a scheme that's been tested and validated before you select even the cultivar. So that's something that I feel that you start clean and then you keep it clean. So that's just, and it's very simple, and dealing with viruses, this is the only way, because you can't cure a plant of viruses. The heat therapy is only when you have little tissue culture plants. So by the time you put it in an orchard, it's gone. You've spent that money and you now have to live with it, which in some cases are almost impossible. So that's the story. So I will now continue to try and tell you how we got to this point, and try not to bore you too much. We were approached by SAPO at the end of 2017 to look at the marbling problem that's been in the industry, like I said, for about 25 years. And this was a serendipitous coincidence between technology and expertise and a need in the industry. So we had access and had been working on high-throughput sequencing or next-generation sequencing technologies for about 10 years. We were some of the early adopters of this technology, and this technology has the ability to, in a metagenomic way, look at a pathogen, at a host, and determine all the pathogens that are present in that sample. Because we are plant virologists, we use it to look at viruses. So very focused, and we used this technology on a small-scale experiment that we had a pilot project, and then we determined through that pilot project that yes, marbling is a disease. There's a new novel viroid associated with it, and the marbling corky flesh symptom is associated with particular cultivars. So some cultivars will manifest a marbling symptom, where other cultivars will preferentially have a corky flesh. So because this was a new pathogen, obviously alarm bells and big problems, and we assembled a small task team to determine the way forward and how we're going to deal with this problem. So like I said, initially we had one project that was to characterize the disease, but then we also got a request from the board to also look at transmission if you were to top work. So was there transmission from an infected tree? If you cut down to the rootstock, if you top work the rootstock, will that scion be infected? And then as the project progressed, we started seeing a need for cheaper diagnostics. So that was the three projects. So if you had to look at, I just need to keep a look at the time. Okay. So, so there's just a summary of the different objectives within the different projects. So first of all, look at the association. Be absolutely 100% sure that this virus is what is causing the disease. Because we can cry wolf and be wrong, and that would be really bad for my career, but also for the industry, because there's money involved in livelihoods. So we developed a diagnostic assay, what we call the first-round diagnostic assay, and then we looked at different methods of transmission, a proper symptom description for different cultivars, a cheaper assay, and then we made sure that the plant improvement organizations had access to this technology. So in the large project, we started characterizing the disease. So we sampled more samples symptomatic and asymptomatic, and we did high throughput sequence on that and confirmed again, like in the pilot project, that this virus was constantly associated with symptomatic material. Additional to that, we also found other viruses that are mostly latent within stone fruits. Like in Rachelle's talk yesterday, we find all these viruses within plants, but they are either not known to cause disease or are not associated with diseases. So when we're talking about clean and healthy plant material from a scheme perspective, these viruses will not make the list, in my opinion, at this point. Until someone has new information, then we adjust. So we did a survey for 2 more years, and we looked at commercial plantings. We had 19 different farms of 8 different regions, and that's the list of cultivars that we found symptoms on. It's important to note here that these cultivars were self-reported, so it's by no means a full scope of the possible cultivars that are affected. These are just the ones that reported it to us, so there's a sampling bias here that should not be ignored. Okay, so then we started developing a more reliable detection assay that could be used to actually look at nuclear and foundation plant material. So we developed, using all the information that we had, all the sequence information, we developed a better diagnostic that's more sensitive, and we also included an internal control. So for those of you that might know what a gel electrophoresis gel look like, this is the result. So that assay works in a way that that's the internal control, so that's just an indication that this is a valid test, which is important if you do diagnostics, because a negative, to make sure that it's a negative, you need some way of knowing that the test works, so that's to show that the test worked. And then the second band shows you that those samples were positive. So sample 1 to 5 were positive, sample 6 negative. Okay, so this is a very sensitive assay. We could get it to work to a dilution of 1 in 10, so you could pool samples to do the diagnostic. Unfortunately, at a very high cost. So between 450 and 600 Rand if you include the labor per test. And it's reliant on good quality RNA, which means there's a level of expertise or skills that's required to be able to process these samples. But this test works throughout the year. So that is an advantage. There's no time point that is actually absolutely essential to work at. But because of the cost, we had a spin-off project to find a cheaper diagnostic. Okay, I will go through the means of spread a bit quicker to make sure I make the time. So to determine if it will spread through graft transmission, we established an experimental orchard, 20 different cultivars, 10 plants per plot, so 10 plants that we grafted with positive material and 10 plants that we left. Because of poor graft take and so forth, we got 72 out of the 120 plants positive. And within the first year, we could observe typical marbling symptoms. So the 2 pictures at the bottom just show that. So plum viroid-1 is definitely graft transmissible. Viroids in general are graft transmissible, so this was not unexpected. So this was not a surprise, and so the symptoms in the first year was a bit of a surprise though. To look for seed transmission, which was a high priority for the project, we identified marbling positive trees. We harvested all the fruits from those trees and made seedlings and tested those seedlings after a year using all the diagnostics that we had, and it all tested negative, which would indicate that this viroid doesn't seem to be transmitted through seed, which is a good thing, which means that our possible restrictions on exports and so things are sidestepped. Then the request for a project to look at top working. We identified an orchard with positive trees. We cut the trees off, or the farmer cut the trees off below the graft union. We allowed 1 bud or a few buds to grow, and that new growth was then grafted with healthy material. And then as soon as we could identify a little bit of growth, we harvested that and tested that for marbling. And 90% of those grafts tested positive. And so the result from this is that obviously top working is a bad idea. From a phytosanitary perspective, it is also a very bad idea. And then, but also then a spin-off is that the test also works on the rootstocks, because we could do that. Okay, we also did a small experiment on mechanical transmission, which is something that is usually possible with viroids. And we did an experiment where we slash inoculated trees. So we would literally take a blade and cut an infected branch and then immediately cut a non-infected, healthy plant. And we do that like 25 times per tree. So it looks like it had some self-worth issues. And then, but after a year, none of the trees tested positive. So, which, again, it's such a small number of trees. We had 50 trees per cultivar, 25 trees per cultivar. It is a small number of trees to do this type of experiment with. So I would say preliminary results would indicate that mechanical transmission is a low probability event. So that, I think, is a safe conclusion. Then if we look at the symptoms, there's a great variation in different cultivars in the symptom expression. Some cultivars would have a light symptom expression, like the one on the left, whereas if you go to the right, you see a more dramatic symptom expression. And for most of the fruits that have a marbling effect on the surface, it doesn't affect the size of the fruit that much or the fruit flesh, except for the one on the left, where it's a very weak marbling symptom, but sometimes the flesh is actually badly affected and it doesn't ripen properly. Then also you have also the corky flesh cultivars that have a severe corky flesh. The fruits are small and hard, obviously inedible. And then the one example where one cultivar had marbling and corky flesh in this one orchard that we still cannot explain why it had the corky flesh. Then more symptoms, that sometimes the surface is uneven, so the fruit will look almost like a golf ball. And then also some of the cultivars will have a size difference in the fruits. Then in terms of symptoms, there are also other viruses or diseases that can cause similar symptoms that should not confuse the process, the identification. So you have ACLSV, which is also a virus that we found, which produces this type of symptom. And then the two Letitia fruits on the right, I don't know what that disease is. We could not identify what it was. And those orchards have been removed and burned. Then other atypical symptoms, but there's a nice information sheet that was prepared with Hortgro that has all the projection is very grainy from my perspective. So, but you can find the nice information sheet if you don't already have it that has a nice description of everything. Also, we found the viroid in apricots in Charisma, and it had a very definitive symptom, and it could be easily identified within an orchard. Okay, so I've got 2 minutes to explain the LAMP assay to you. We had an idea for a cheap assay. It didn't work. COVID shot us in the foot and hampered progress quite badly. But what COVID took away, it also gave us. Because through development companies, they developed LAMP assays that worked from RNA, which is fantastic for us. So we used a LAMP assay that works from RNA to create a cheaper diagnostic. So this was a test that we workshopped, and people actually in the audience did the test. So it is basically a small test. You take a piece of plant material, you grind it up in a solution, and then add a mixture to it, and then it will either be pink if it's negative or yellow if it's positive. As you can see, the problem comes in when do you decide when it's pink and when it's yellow. So that gets a bit ambiguous. So we have an alternative where you do a real-time LAMP, where you measure the accumulation, and if you have the right instrument, you are now not ambiguous. You don't have such an ambiguous result anymore, but then you can more clearly differentiate between positive and negative. So this test doesn't cost more than the previous one. It's the same price, except this one you need a special instrument, which is 500,000 Rand or something. But small change, no? Okay, and all this information has been provided to Plant Improvement. They came to our lab, we went to theirs to make sure that all the tech transfer happened. We also published all the information, so it's all available for someone else who'd like to do it. And with that, I would like to thank all the producers that allowed us to work on their farms. It is a fantastic group of people to work with. We really liked working with all the producers. Everyone was friendly and nice to us. And obviously, the marbling task team, thank you very much. It was a wonderful ride. Thanks, Jess.